Hello, my name is James Lewis, professor, and we're going to be talking about the eruption of Toba that occurred 73,000 years ago. It's had a huge impact on society, and if things went a little bit worse during this time, then maybe we wouldn't even be here today. So let's begin. The cause of the eruption: Mount Toba is located in Barisan Mountains, north central Sumatra in Indonesia. The Earth's biggest quaternary caldera that was formed from four eruptions. The quaternary is a repetition of catastrophic eruptions that occurred 1.6 million years ago. The caldera eruptions are very aggressive eruptions that forcefully blast ash, pumice, gas, and other particles. And the caldera is a special volcanic form, and that's why on the right side you can see the faults, and that's why now that there's a lake, and because it formed that crater. Toba erupted from ring fractures that surrounded all of the lake. So after these eruptions, the ring fractures around the lake served as volcanic vents. And so as the magma chamber empties, everything within the ring fracture collapses. So what occurred during the eruption? 73,000 years ago, Toba released an estimated 2,800 cubic kilometers of ash and lava. And on the right side, the bottom right, you could see it puts it into perspective how massive this was. And volcanists even said that this could be one of the largest eruptions in human history. The volcanic explosivity index was 8, and the VEI measures the explosiveness of eruptions, and 8 is actually the max that you could have. It deposited a layer of ash that was 15 centimeters thick, and this covered the whole South Asia with 6 inches of ash, and it was also deposited over the Indian Ocean, the Arabian Sea, and the South China Sea as well. Toba deposited 1,800 cubic miles of magma that was enough to fill the Grand Canyon 200 times. The eruption also caused tsunamis to occur along the coast of Australia, Malaysia, Myanmar, Madagascar, and Africa as well. Let's go to the next slide. The end result of Toba. So Toba created death of animals, wildlife, and Homo sapiens because of the volcanic ash and magma. Toba created a huge risk of wiping out all of mankind. So evidence found that the Homo sapiens already were migrating to India before the eruption. So some of them were saved, but there were many that had a tough time because they didn't migrate fast enough. And this leads me into my next point, talking about another struggle that they faced. The volcanic ash blocked the sunlight from hitting the earth, causing a climate change for upwards of 6 years and low temperatures for about 1,000 years. The ash suppressed temperature because the sulfur within the ash was not allowing the sunlight to peek through. So the change in temperature resulted in loss of population, creating a bottleneck in human evolution. When there's low numbers, there's a small percentage to recover, and then this can also risk extinction. And that's why it's so interesting now to see that this could have risked our civilization and our living as well. The Toba catastrophe, they emphasize that 90% of Homo sapiens died and left only 10% to repopulate the earth, which is super low considering how extinction and the recovery statistic works. The next slide, we're going to figure out how did this occur. Greg Zelensky analyzed the composition of each annual layer in the ice core and found tiny chemical fluctuations that correspond to periodic shifts in temperature and climate. So many people might ask, like, how do we know if this happened 73,000 years ago? And it's so great now with technology and everything that we can see through the ice cores and everything like that, and through the ash DNA signatures as well. A geologist, Michael Rampino, measures the ratio of these two forms of oxygen and also analyzed the ocean core from all around the globe. He found that there had been an increase in chemistry of the ice cores, meaning something caused lower temperatures, and many people think that this was an ice age effect from this eruption. John Westgate was researching where the ash comes from, and he uses DNA signatures to track it to its parent volcano. samples from the locations thousands of miles apart were the same age, and they tested the composition of the ash. So it just goes to show you how far and how much of a span there was of ash, and you can see in the left hand side how much it extended to. So I really thank you for your time, and I hope you have a great day. This is my excited sheet as well. So I thank you very much.